So this is where we left off. We found our axis of symmetry because we're in standard form for a quadratic equation. Axis of symmetry is x equals negative b over 2a. I have to find the y coordinate for the axis of symmetry. That gives me my vertex. I found it. It's 12 1/4. So I marked it. I have my y-intercept for this equation. It's positive 12, so I marked it, and then I reflected it across. Then I picked some easy numbers, 1, 2, 3. I'm using my first equation here, substitute them in, and I get those ordered pairs, reflect across, and it gives me my other ordered pairs that I'm going to be using to graph. If I need to, or if I wanted to, I could go to x equals 4, plug it in, and maybe get a third point or another point all the way down here. I will do that for sure if my other equation winds up crossing down here somewhere. Then I'm going to need to know for sure if that parabola that I just drew goes through that point, okay? These parabolas are probably going to cross through some sort of dot that you put down. So the more dots you put down, the better your chances are going to be for finding this thing. So, put a 4 on there. 4 squared is 16. Now make it negative, so negative 16. Negative 16 minus 4 would be negative 20, and then negative 20 plus 12 is negative 8. We're going by 2's on this axis, so that means 2, 4, 6, 8, all the way over to 4 right here. There's my dot. Then I'm going to reflect that across. Now when you reflect, be very careful. Remember where that axis of symmetry line is. My axis of symmetry happens to be halfway. So that means I got to go 1, 2, 3, 4 and a half to get to my axis of symmetry. So I got to go 4 and a half again. 1/2, and then 1, 2, 3, 4. The reason I'm bringing that up is because on the homework there's one problem, or maybe two problems, that have an axis of symmetry of like 1/4 or something like that. So when you reflect, you're only going to like 1/4, which means you got to go 1/4 on the other side. Or if you're going the other way, you're going 3/4 to the axis of symmetry, like 2 3/4. So you have to go 2 3/4 again. If you don't do that, they're going to wind up with sort of a lopsided looking parabola. So just be very careful as you come up with those numbers, and then as you plot those points. For my second equation, I'm changing colors, and again I can't put that one in vertex form very easily, so I'm not going to, but the first thing I need to do is what? AOS. We're just graphing it, we're not trying to solve it. Okay, so we needed an AOS. X equals negative 7 over 2 times 1, so negative 7/2, which is negative 3 1/2. So negative 1, negative 2, negative 3. Here's 3 1/2 right here. I'm going to put that axis of symmetry on there. Now my vertex is somewhere on that line, which means I need to include negative 7/2 in my table. I have to find that one. I have to find the vertex. Then I should choose some easy numbers to either side. What are some easy numbers I could pick? Yeah, we have negative 3, negative 2, negative 1. 0 I already know is 12. So I can put 0 on there and get 12 instantly if I want to. And then I can go negative 1, negative 2, negative 3. So 0, 12, I already know is on my graph, and I already know that it's an intersection point. Since my vertex is somewhere on this line, I'm guessing it's probably somewhere in this region here. So I'm guessing that this dot or this dot is going to be my other answer. We'll see. Take negative 7/2, plug it in. Just use your brain a little bit. Negative 7/2 squared becomes what? Positive 49/4. Plus 7 times negative 7/2. 7 times negative 7/2 would be negative 49/2. So if I have 49/4 here, and then negative 49/2 here, what do I get? Negative 49/4. Good. It's kind of like if I had 1/4 sitting here and negative 1/2 sitting here, I'd wind up with negative 1/4. Well, here I have negative 49 fourths, negative 49 halves, so I'm winding up with negative 49 fourths. Negative 49 fourths plus 12. I need a common denominator there. My common denominator is going to be fourths. We're in fourths, right? So 4. 12 will turn into 48. So I got negative 49 fourths here plus 48 fourths here, which gives me negative 1/4. And I can mark that here. Okay, start picking some other numbers. We have negative 1. Of course, now it's going to be a lot easier to work with that. This one took a lot of thought to get through, but the rest of these shouldn't be too bad. Negative 1 squared is 1. Negative 1 times 7 is negative 7. So we have 1 minus 7, which is hopefully negative 6, plus 12, which is 6. So for negative 1, I'm at 6. 2, 4, 6. I can reflect it. 1, 2 and a half. 1, 2 and a half. I can reflect this one. 1, 2, 3 and a half. 1, 2, 3 and a half. I can kind of tell where that other intersection point is going to be right now, but we have to do it anyway. Take negative 2 and plug it in. Negative 2 squared is 4. 7 times negative 2 is negative 14. So I get out of this negative 10 plus 12, which is 2. Mark it. Reflect across. And finally, negative 3. Plug in. Negative 3 squared is 9. Minus 21 is 12. Plus 12 is 0. So I get negative 3, 0, which is right there. Then I reflect that across, and I land exactly on that dot right there. So now I know my two solutions. I do still have to draw the parabola in there, though. And now I label my solutions, which are, this one is negative 3, comma 0, and this one is 0, comma 12. Just like we found over here. Which way is easier? Oops, sorry, negative 4. Negative 4, comma 0, this one right here. So just like we found over there, which way is easier? Algebraically, for sure. Okay. So for this one, algebraically, what should we do first? Set them equal to each other. So I'll write x squared minus 4x plus 5 equals negative x squared plus 5. Now what? Move it all over. Which way should I move? Yeah, I like the x squared to be positive, so I'm going to add x squared, which makes me subtract 5. Add x squared, which makes me subtract 5. And now I have, what? 2x squared minus 4x equals 0. Okay, now what? See if you can factor it. Does this factor?
Yeah, 2x.
2x. Yeah, there's a GCF of 2x. So I write 2x and then open parentheses. What's left over? X minus 2 equals 0. Now what am I supposed to do? Zero product property. So 2x equals 0. X minus 2 equals 0, which means x equals 0. X equals 2. So now I know the x coordinates of my intersection points. What do I do now? Plug them into one of the originals. I don't know which one looks easier to you. Which one do you want to pick? The bottom one? Okay. So we take 0, plug it in. 0 squared is 0. Make it negative. It's still 0. Plus 5 is 5. So we get y equals 5 for that guy. And now 2 plugged in gives me what here? Negative 4. Plus 5 is what? So my answers are 0, comma 5 and 2, comma 1. We'll continue with this problem again, doing it graphically. Take a look at that first equation. How do you want to graph it? You want to use standard form, or do you want to try to put it in vertex form? Look at the equation. Can this be put in vertex form easily? Yeah, because B is even, and there's no GCF to factor out or anything like that. Okay? So this is going to be easy to put in vertex form. I draw my grouping symbols there to make me realize that I need to take half of B and then do what to it? Square it. So if I do that, then I have y equals x squared minus 4x plus what? Plus 4. Half of negative 4 is negative 2. Square it and you get positive 4. And then outside I have the plus 5 minus 4. And now it's in vertex form. Y equals what? X minus 2. Don't forget the squared. And then the plus 1. So now it's easily in vertex form. There's no fractions to worry about here. So I can graph this thing probably fairly quickly. Where do I start? Yeah, positive 2, 1, right there. That's my vertex, which makes that my axis of symmetry. Now what? Okay, easy numbers. First of all, I already know one other point right now. The y-intercept is 5. So I can mark that, 1, 2, 3, 4, 5, and I can reflect that across. So probably if I pick this one here, if I put 1 in, I'm going to have a pretty good looking parabola already. So if I plug 1 in here, 1 minus 2 is negative 1 squared is, plus 1 is 2. So I know I have that dot right there. And I reflect that across, and I can see that parabola pretty well. So I draw in my nice smooth curve. Look at how much less work there was here once you put it in vertex form. Can I put the other one in vertex form? Yes? No? It's already in vertex form. Do you see it? Yeah? You don't distribute. The parentheses just aren't there. And there is no h. If I were to rewrite this in the vertex form you're used to seeing, let me put it in red, we have y equals the negative sign out front, in parentheses, x minus 0 squared plus 5. The minus 0 would go away, and it would simplify down to negative x squared plus 5. Okay? It already is in vertex form. So where do we start? 0, 5 is my vertex, which also happens to be an intersection point. Which way does this parabola open? Down. Okay. What else do I need to do? How about axis of symmetry? Should probably pick a couple easy numbers here. Take 1, plug it in. 1 squared is 1. Make it negative. Plus 5 is 4. So there's a dot reflected across. Take 2, plug it in. 2 squared is, make it negative. Plus 5 is 1. So here's 2, there's 1, there's my other intersection point. Reflected across. I already know what my answers are, but let's do one more. Take 3, plug it in. 3 squared is, make it negative. And then plus 5, negative 4. So 3, negative 1, 2, 3, 4. Reflect across, 1, 2, 3, 1, 2, 3. So there's my second parabola. Draw a smooth curve. You have to do this anyway, because you still have to graph it. And then you can list the ordered pairs. They are 0, 5, and 2, 1. Same answers that we found the other way. Vertex form, way easier. All right, for inequalities, the nice thing about inequalities is you don't have to find the intersection points. We don't actually care about the intersection points most of the time, unless you're asked, or unless it's a feasible domain where you're doing linear programming. With inequalities, go think back to the smiley face that we did at the beginning of the section. You're just going to graph the parabolas as you have been doing, and then figure out which way to shade, and then shade the region that you're supposed to shade. So, take a look at this first one. Y is less than negative x squared minus 9x minus 2. What is that parabola doing? It opens down, and when we graph this, it will be shaded below, and it will be dotted. Yeah. So with inequalities, we have to remember we're going to have dotted or solid, and we're going to have shading above or below. Okay? Otherwise, you graph it exactly like you normally would. So with this one, is it going to be easy to put it in vertex form? 9 is not an even number. So we're going to wind up with fractions if we try to put it in vertex form. You want to deal with that? Okay, so good. We want to start off with AOS. X equals what? Negative 9 divided by 2 times negative 1, which is negative 2. So negative 9 halves, negative 4 1/2. Negative 1, 2, 3, 4 1/2. Here's your axis of symmetry. Set up your table, x and y. You have to choose the vertex, negative 9 halves. And then you have to also choose some other easy numbers, hopefully, to the left or to the right of the axis of symmetry. For me, I'm going to pick what?
0.
I got negative 9 halves here. How about negative 4, negative 3, negative 2? By the way, I do know another ordered pair right now. 0 is negative 2. The y-intercept is negative 2. Yeah. So because this parabola opens down and my y-intercept is negative 2 and my axis of symmetry is all the way over here, I'm actually a little suspicious that I might have to rescale this one. So I'm going to leave this alone for now. But I do know my axis of symmetry is negative 2. So let's find the vertex, and then we'll be able to decide if we need to rescale or not. Take negative 9 halves and just very slowly plug it in. We have negative 9 halves squared, which is what? So 81 fourths. But then the negative up front says make it negative, so that's negative 81 fourths. Then we have negative 9 halves times negative 9. Positive 81 halves. And then we're going to subtract 2. So we have that same situation again. Negative 81 fourths plus 81 halves. What do we get? Positive 81 fourths. Good. And now we need a common denominator here. 4. So the 2 turns into 8 fourths. So we had positive 81 fourths minus 8 fourths gives me close, 73 fourths. Well, what the heck is 73 fourths? Probably kind of a big number. Bigger than 10?
Yeah.
Bigger than 20?
No.
What is it? 18.25. So I only have 7 lines here, which means I am going to have to change my scale. What scale would be good?
No.
By 2s gets me to 14. I got to get to 18. By 3s? So that gets me all the way to 21. So 18.25. 3, 6, 9, 12, 15, 18, and then 0.25 just above the 18. That's the hardest part. From there, you're picking the easier numbers to work with. So we take negative 4 Plug it in, that's 16, but make it negative, so negative 16. This is positive 36, so I'm left with 20. 20 minus 2 is 18. So I can mark that one there and reflect it across. Take negative 3, plug it in. Negative 3 squared is positive 9, but then make it negative, so negative 9. Negative 3 times negative 9 would be positive 27, leaving me with what? We have negative 9 plus 27. 18. Minus 2 is 16. So for negative 3, we're at 16. 3, 6, 9, 12, 15. So 16 is a third of the way up. Reflect it across. Negative 2 squared is 4, but make it negative, so negative 4. Negative 2 times negative 9 is positive 18, leaving me with what? 14 minus 2 is 12. So 2, 3, 6, 9, 12. Right there, reflected across. 1, 2 and a half, 1, 2 and a half. If I keep going, I'm going to get a really nice looking parabola. But how about I skip a couple numbers and put that 0 in there? We already know what it is. Negative 2. So we have 0, negative 2, which is about 2/3 of the way down. Reflected across. 1, 2, 3, 4 and a half. 1, 2, 3, 4 and a half. Maybe right about there. I'm already off of my grid over here, so I don't need to worry about any more dots down here. If I want to, I could put 1 in there and get one more dot down here. But here's my parabola. Is it supposed to be solid? Oh, it's terrible. It's supposed to be dotted. So, like you guys, I go back in with my eraser and make a nice dotted parabola. And which way are we shading?
Below.
Below. So I'm going to draw little arrows down, reminding me that I'm shading below. Okay, so now we draw the other one in there. Can I put that one in vertex form? It is in vertex form. What's the vertex? 0, negative 2. And my scale is by 3s, so I'm sitting right there. We have an axis of symmetry down the y-axis. Now I can just pick points and hopefully come up with something that looks pretty good. So I can pick 1. Squared is 1. 1 minus 2 is negative 1. So I'm there. Pick 2. Squared is 4. 4 minus 2 is positive 2. So I'm there. Pick 3. I have 9 minus 2, which is 7. So here's 3. 3, 6, 7 is there. Maybe pick 4. 16 minus 2 is 14. 4. And then 14. So 3, 6, 9, 12, 14 is 2/3 of the way up. That looks pretty good. So I'm going to reflect those across. 1, 2, 3, 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. This parabola is supposed to be dotted and shaded above. So I'm going to remember to draw a dotted parabola in this time. And then I'm shading above. So the region that's getting hit is this region right here, this fingernail. And that's your answer. So how about this last one? What should we do? You want to do vertex form on that top one? That's an even B. I am going to have to factor out something though. A negative, which is not that big a deal. So I put my grouping symbols there. I'm going to rewrite this. Y is less than or equal to what? Negative out front, and then plus 4x leave a gap, and then the plus 3. So complete the square inside. Divide b by 2 and you get 2. Square it and you get 4. So I have plus 4 here, which means I need to do what?
Add a 4.
We're going to add 4, yeah. Because if I distribute that negative sign back in, this is actually a negative 4 that I just put in there, which means I need to add 4 to keep the equation in balance. So plus 4 there. Now it can be written in vertex form. Y is less than or equal to the negative sign. X what? Plus 2 squared plus 7. Which way is this parabola open? Down. Where's my vertex? Negative 2, 7. And because it's at negative 2, positive 7, and it opens down, I probably don't need to rescale this, which is nice. Axis of symmetry. Pick some easy numbers. Negative 1. How about negative 1? And 0, I already know. What is it?
3.
It's 3. The y-intercept is 3. So 1, 2, 3. I know that one already. Reflect across. Plug negative 1 in. Maybe plug positive 1 in. So negative 1 plugged in gives me what right here? Negative 1 squared is 1. But then make it negative. Negative 1 plus 7 is positive 6. Reflect it across. One more. Positive 1 plus 2 is squared. Make it negative. Plus 7 is negative 2. So positive 1 is at negative 2. Reflect across. 1, 2, 3. 1, 2, 3. Probably good enough. Drawing that parabola. This thing is going to be solid or dotted? Solid. There you go. And which way are we shading? Below. Okay, the second one. How do we want to graph that? It's already in vertex form. So where's my vertex at? 0, 3. 1, 2, 3. Now what? Okay. Axis of symmetry is the y-axis. Now what? Some easy numbers. All right. So let's do 1. So it's 1, 4. And let's try 2. 2, 7. So we're already at the edge of the graph. Reflect across. And then what kind of parabola are we drawing here? It's dotted. And we're shading which way? Above. So which region is getting shaded here? Yeah, the little fingernail. On your calculators will do exactly this. So bring up your calculator, bring up the graph, make sure it's not blinking. Bring up your graph and you'll have your function window that says f1 of x equals. With your cursor in that function window, press delete on your graph. Bring up your graph. In your function window at the bottom. Mine looks a little different than yours does. Yours is at the bottom, mine's at the top. Press delete. And then it doesn't like to stay on the screen. So press delete and it will bring up all of your inequality symbols that you might use. So let's enter this one in right here, this bottom one that we just did, just because it was actually on the window. So I want less than or equal to, so I select less than or equal to, and then it switches from function notation to y is less than or equal to. It does that because it's no longer a function. Inequalities are not functions. They don't pass the vertical line test. And then I'm just going to type in that. Make sure that you're typing in the negative sign for negative signs and minus signs for minus signs. That is a negative x squared. So I type negative x squared. Minus 4x, so I'm using minus this time, 4x, and then the plus 3. Hit enter, and it gives you the graph, and it's shaded.
I thought we were doing the bottom one.
We are doing the bottom one.
The bottom system.
The bottom system of inequalities.
That's what mine came up with.
Well, then you used the wrong symbol. You needed the less than, not the greater than.
But there's no.
You'll notice that the boundary is actually solid. When we graph the other one, you'll notice that the boundary is actually going to be dotted. So to do the second one, press tab to bring up the function window again. Delete the equal sign, and this time we want to see the greater than symbol, so that's that one. And then we just type in the rest of the function. So x squared, and then the plus 3. Hit enter, and there's your second parabola. Yours will come up as two different colors, which is really handy. Mine, for some reason, came up as basically the same color, but you can see where that region of overlap is. And if you look closely at this function, you can see that it's dotted. Like if I move my cursor on top of it, I can see that there's dots there. So that's a nice way to check. Obviously on the test or on the homework, if I'm asking you to graph and show me that shaded region, you're not going to be able to do that on the calculator and then be able to like print it off on your graph. So you're still going to have to know how, but you can check on the calculator. Okay? At the same time, let me back up here. Let me get out of the inequalities, if it'll let me. And let's redo this one right here. So I'm going to bring my calculator back up. And since I'm on the scratch pad, I'm just going to close that. And then I'm going to press calculate. Oh, sorry. I'm just going to close that. On a document page, I can go back to home and I can insert a graph. And it gives me a brand new graph. You're just going to a new graph. You can delete what you just did. Oh, sorry. It's the last equation system. Okay, so on your function window, then type in those functions. We have x squared, and then minus 4x, and then plus 5. Hit enter. And then press tab again. Brings up f2 of x. And then you can type in, make sure you use negative, and then x squared, and then plus 5. Hit enter. And now you can see your two parabolas. And if you want to find the intersection, then you can just find the intersection. So you're going to press menu, and which one? Analyze, and then intersection. And then it's going to ask you lower bound and upper bound. You can only find one intersection at a time. The lower bound needs to be on the left side. Click, and then just slide across until you get that intersection point and click, and it tells you it's 0, 5. Then do that same thing again for the other intersection point. So I got to repeat menu, analyze, intersection is number 4. This time I need to be on the left side of this intersection point, but not on the left side of the other intersection point. The calculator will get confused. So I need to be in this region right here. Click and then slide across, and it will give you the other intersection point, which I actually can't read. So I'm going to grab it. I'm going to try to grab it. It'll let me. It's not going to let me. 2-1. You need to slide across. Once you click intersection on one side, then you slide across. When it shows you that intersection point, click again, and it will get out of that for you.
Right, but I wanted to do the top one now.
So lower bound, you need to be on the far left of the point that you're looking for. It doesn't know. You have to tell it. Okay, so you're trying to surround one only. Okay, so the point of this is the calculators will do this for you. It will help you. If on the test it's a multiple choice problem and I'm asking you what are the intersection points and you want to do it this way, fine. Just make sure you get it right because you won't get any partial credit if you don't show me any work. On a test, if I'm asking you to graph and I give you a grid, I still have to see all of the work that we did here. But you're more than welcome to check your answer here. That way you'll know you're right. All right?